Welcome everyone in lecture number 3 of Laplace transform. In this video lecture we will learn about first shifting theorem of Laplace transform. So let me first state the theorem. Statement is if Laplace transform of any function ft is suppose fp, where fp is any function of p, then Laplace transform of e raised to the power at ft will be f of p minus a. Means if we are given this, means if we know the Laplace transform of function ft, then we can find the Laplace transform of any function of the type which is e raised to the power at ft. Means the function is multiplied by exponential function. So such type of function is new function. So the Laplace transform of this new function is obtained by simply replacing p by p minus a in fp. Means you are given ft, suppose, and you have to find the Laplace transform of e raised to the power at ft. Means whatever is multiplied by exponential function is ft. मतलब ft वो फंक्शन होगा जो एक्सपोनेंशियल फंक्शन से मल्टीप्लाई हो रहा होगा, दैट इज ft. तो आप ft, ये ft है, तो आपको क्या करना है कि ft का लाप्लास फाइंड आउट करना है, लाप्लास ट्रांसफॉर्म ऑफ ft. इससे आपको fp मिल जाएगा. अब fp की हेल्प से हम लाप्लास ट्रांसफॉर्म ऑफ e raised to the power at ft, इस फंक्शन का लाप्लास ट्रांसफॉर्म कैसे फाइंड आउट करेंगे? हम इस फंक्शन को रिप्लेस कर देंगे इस फंक्शन में, p को p से p माइनस a से रिप्लेस कर देंगे. So suppose if we have negative a here, then p will be replaced by p plus a. So this is called the first shifting theorem. So if Laplace transform of ft is fp, then Laplace transform of e raised to the power at ft will be f of p minus a. हम इसे नेगेटिव पावर के लिए भी लिख सकते हैं. If Laplace transform of ft is equal to fp, then Laplace transform of e raised to the power minus at ft will be f of p plus a. Now p is replaced by p plus a because of this negative sign. So let me quickly take up one example to make you understand this property. Example is evaluate Laplace transform of e raised to the power at cos of bt. इसमें आपको हमेशा ऐसा फंक्शन मिलेगा जिसमें एक्सपोनेंशियल फंक्शन जरूर होगा. तो अगर किसी भी फंक्शन में एक्सपोनेंशियल फंक्शन से मल्टीप्लाई हो रहा है तो आप उसमें इस प्रॉपर्टी का यूज करके उसका लाप्लास फाइंड आउट कर सकते हो, क्योंकि product of these two functions become complicated, and if you use the traditional definition of Laplace transform in finding the Laplace transform, then this will become quite very tedious. So to make it simpler, we make the use of this property. So first of all, we extract ft from this expression. So ft is cos of bt. right? This is ft because this function is multiplied by this exponential function. So what we do is, in solution, we first of all find the Laplace transform of cos of bt. So we let here ft is equal to cos of bt, so that Laplace transform of cos of bt, ये हम अपने प्रीवियस लेक्चर्स में डिस्कस कर चुके हैं. इसका लाप्लास ट्रांसफॉर्म क्या होगा cos bt का? cos bt का लाप्लास ट्रांसफॉर्म होगा p अपॉन p स्क्वायर प्लस b स्क्वायर. So this is denoted by fp. This is our fp. So by first shifting property, Laplace transform of e raised to the power at cos bt will be the function fp. This is function fp. In this function fp, p will be replaced by p minus a, right? So what we write is, this implies Laplace transform of e raised to the power at cos of bt will be p minus a whole divided by p minus a whole square plus b square. And this is the correct answer. Okay. Uh, let me do second example. Evaluate Laplace transform of e raised to the power minus at t raised to the power n minus 1 whole divided by n minus 1 factorial. Again the procedure is same. First of all, we find out the function ft. So this function ft will be t raised to the power n minus 1 whole divided by n minus 1 factorial. This implies Laplace transform of ft is 1 upon n minus 1 factorial. Because this is a constant, we apply L on t raised to the power n minus 1 by linearity property. And if you remember, let me recall, Laplace transform of t raised to the power n is gamma n plus 1 whole divided by p raised to the power n plus 1. So Laplace transform of this t raised to the power n minus 1 will be 1 upon n minus 1 factorial. Here we have n minus 1, and whenever we have n here, this will 1 is added to the power. So when 1 is added here, we will get gamma n whole divided by p raised to the power n. So we simplify it. Let me enclose this in a box. because this is a property that we are using here. Okay, so this is equal to, I've told you when n is a positive integer, this gamma n is n minus 1 factorial. Because in question we are given n in terms of factorial, so we suppose that this is an integer, positive integer. So we can safely use the property that gamma n is equal to n minus 1 factorial. So we replace this gamma n by n minus 1 factorial, whole divided by p raised to the power n. So this cancelled out with this term. What is left here is p raised to the power n, 1 upon p raised to the power n. So this is the Laplace transform of ft. So this is denoted by fp. Now we come back to the original function. By first shifting property, we will write by first shifting property, Laplace transform of e raised power minus at t raised power n minus 1 whole divided by n minus 1 factorial is equal to the function fp. In this function fp, p is replaced by p plus a because a is negative here. So the answer is 1 upon p plus a raised to the power n. This is the answer. I think the whole procedure is quite understood. Let me do one more example. Example number 3. Find Laplace transform of e raised power minus t sine of sine square t. The solution is, first of all, we extract ft from this expression. So ft will be sine square t. So Laplace transform of ft is equal to Laplace transform of sine square t. So we have to find the Laplace transform of sine square t. We know the formula of cos 2t in terms of sine square t. Cos 2t is equal to 1 minus 2 sine square t. So the value of sine square t is equal to 1 minus cos 2t. So Laplace transform of sine t is equal, sine square t is equal to Laplace transform of 1 minus cos 2t. And this whole term is also divided by 2 here. So 1 upon 2 will take outside, and this is equal to Laplace transform of 1 minus Laplace transform of cos 2t. So Laplace transform of 1 is 1 upon p and Laplace transform of cos 2t is p upon p square plus 4. So this is equal to fp. So by first shifting property, Laplace transform of e raised power minus t sine square t will be equal to 1 upon 2p minus p upon 2p square plus 4, which is fp. This whole expression is fp, and here p is replaced by p plus 1. We can leave it as it is, or we can just replace p by p plus 1 and write the expression again. So this is 1 upon 2p plus 1 minus p plus 1 to p plus 1 whole square plus 4. This is the answer. So this is what we have discussed today is first shifting property, which is very useful property in finding the Laplace transform of product of two functions, where one of the function is exponential function and another function is such that you can find the Laplace transform of that function. So if you have liked my lecture, and if you want the notification of more lectures, more new lectures on Laplace transform, you can subscribe my channel, and you can share it also and press the like button. Thank you very much.